Hello everyone, welcome to today's class. And in this class, we are going to be discussing a very important topic, which is our energy and what chemical reaction. Now, this topic is important and it's necessary you get an understanding of it if you are preparing for your JAMB UTME, for any external examination, or even your class exam. And if you are coming across this YouTube channel for the first time, my name is Basi Ejogba. I'm a student in the University of Calabar studying medical laboratory science, and in my channel, I help students level up their academic game. I also share footage on the channel focusing on personal development. So if you love content like this, please don't forget to hit on the red subscribe button so I can continue getting updates anytime I drop videos like this, and so that you can help me grow. And just like I've said, we are going to be discussing about energy and what chemical reaction. It's common knowledge, or it's something that we already have to know what is our energy and what chemical reaction. We all know that energy is the ability to do what work. So we say energy is the ability. So this is our energy. Energy is the ability to do what work. So energy is the ability to do what work. It is necessary, and it's noteworthy to know that without energy there will be no ability to do what work. And we also have to understand that energy can neither be created nor destroyed. This is a very important concept, or a very important law. You are supposed to know that energy, you have to know that energy can neither be created. So energy cannot be created nor destroyed. Energy cannot be created nor destroyed. That means you cannot create energy, neither can you destroy energy. But rather, instead of destroying this energy can be transformed from one form to another. So this energy can neither be created nor destroyed, but emphasis on the word but can be transformed. But can be transformed, right? So it can be transformed, or that means it can, what this means that it can be changed from one form to another. And we have our types of energy. So we say types of energy, right? When it comes to our type of energy, we have our potential energy. So we say we have our number one, which is our potential energy. We have our potential energy, right? We have our potential energy. We have our kinetic energy. We have our kinetic energy. We have our light energy. We have our light energy, right? We have our light energy, we have our mechanical energy, and a lot of types of energy. So that is just how it is, right? So now let's talk about chemical reaction. When we talk about chemical reaction, it is not something that is new, because as chemistry student or as science student, we have been hearing about reaction, and chemical reaction. So chemical reaction is simply the process that gives rise to the formation of a product, right? So a chemical reaction gives rise to a formation of what is known as a product. So a reaction give rise to what is known as a product. So for this to take place, that means there must be something, or there must be two things that will give rise to this product, and that is what is known as the reactants. So we have our reactants. So to get a product, that means a reactant must combine, which is plus a reactant. So say a reactant plus a reactant will give us what is known as a product, right? A reactant plus a reactant will give us what is known as a product. I talked about this in depth when I was talking about rate of chemical reaction. Based on the rate of chemical reaction, we know that a reactant plus a reactant will give us a product, and a reactant plus a reactant will not just take place if there is nothing that is known as a collision. So when there's a reactant plus a reactant, which is overall process, which is known as a reaction. This is a reaction. For this reaction to take place, there must be something that is known as a collision. That means a collision must takes place, and we all know that it's not all of this collision taking place that will give rise to the formation of this product. It is just a fraction of this collision that will give rise to a product, and this small fraction of collision that will give rise to this product is what is also known as the effective what is also known as effective collision, right? I talked about this in depthly when we're talking about rate of chemical reaction. So check out that video based on rate of chemical reaction, and you will get to see everything I'm talking about in this video. And we are not going to be wasting time to be discussing on things that are not really necessary, especially for those of you that will be preparing for your JAMB UTME, that will be using this video to prepare for your JAMB UTME. So we are going to be talking about what is a rate of a reaction, right? Let's talk about what is rate of reaction. Now this is a reactant plus a reactant giving us a product, and we say this is total. This process is what is known as a reaction, right? Now a rate or heat of reaction the heat of this reaction. So we say what? Heat of what? Reaction. Heat of what? Reaction. Right? The heat of reaction is the what? Energy what? Change. Right? So let me get it directly here. It says the heat of reaction is the energy change which accompanies what? A chemical what? Reaction. So heat of reaction is the what? Energy change. Is the what? Energy what? Changes. Or is the energy what? Change which is the energy change which accompanies what? A chemical what? Reaction. Which accompanies a chemical what? Reaction. So which accompanies a chemical what? Reaction. So this is a reaction that is taking place, a reactant plus a reactant giving you also a product, right? Now the heat of reaction, right? The heat of reaction is this energy change which accompanies what? This reaction. So for any reaction that is taking place, heat must always be what? Heat must always be what? Giving what? Out, right? So heat is what? Evolve. Heat is what? Giving what? Out. And when heat is giving out, note when I was talking about it in the rate of chemical reaction, I say when heat is giving out, such a reactor is known as what? An exothermic what? Reaction, because it is what? Exo, it is what? External, is giving what? Is giving out what? Heat. So the heat of reaction is the energy change which accompanies what? A chemical what? Reaction, right? So please take note of this, and also note about all these concepts, because basically what I will be doing is to be listing out this concept, and it is very, very important that you write down all of this concept. We say that an internal energy of a system is known as what? An enthalpy. The internal energy of a system is what is known as what? Enthalpy. So let's write it down. And we say our what? Enthalpy. Right? This is our what? Enthalpy. Right? The enthalpy is the what? Is the internal energy. So the enthalpy is what? This is the what? This is the what? Internal energy. So this is the internal energy. This internal energy of a body of a system is the internal energy of a, let me see here, is the internal energy of what? A system. This is internal energy of what? A system. That is what enthalpy is all about, the internal energy of what? A system. And there's also another concept which is based on the what? Degree of disorderliness of what? A system. Based on a particular system, the degree of disorderliness that takes place in this system is what is also known as what? Entropy. So we also have another concept which is known as what? Entropy. And we say our entropy is what? This is the what? Degree of disorderliness of what? A system. So we say a degree of what? Disorderliness. We say entropy is a degree of what? Disorderliness. The degree of disorderliness of what? A system. Please, it's very, very important you are able to differentiate between what? An enthalpy and what is also known as what? Entropy, which is already on the board. Now when we are talking about this what? Heat of what? Reaction, which you say is the what? Heat what? Change that accompanies what? A chemical what? Reaction. This heat of reaction is what? Measured, and the unit for measuring a heat of reaction is what is known as the what? Kilocalories, right? The unit for measuring heat of reaction is known as what? Kilowatt calorie. So say the kilocalorie is a for measuring unit for measuring what? Heat what? Change. For measuring what? Heat what? Change is what? The kilowatt calories. So the kilowatt calories is the word kilowatt calorie. Now what is what? The kilowatt calorie, right? What is the word kilowatt calorie? This is the word amount of what? Heat. Please take note. The kilocalorie, let me write kilocalorie. This is the word amount of what? Heat. This is the word amount of what? Heat. This is the amount of what? Heat needed to raise the temperature of 1 kilogram of what? Water. This is the amount of what? Heat. This is the amount of what? Heat needed. This is the amount of what? Heat needed to raise the temperature. Needed to raise the temperature. Needed. This amount of heat needed to raise the temperature. Needed to raise the temperature. Right? Needed to raise the temperature of 1 kilogram. So of 1 kg of 1 kg of water, of what? Water by what? 1 degree what? C. So this is the unit for measuring what? That heat of what? Energy, which is the heat accompanying what? Energy what? Changes in the what? A reaction. It says is the amount of what? Heat needed to raise the temperature of 1 kilogram of what? Water by what? 1 kg. Now note that 1 kilocalorie is equals to what? 1000 what? Calorie. So we say 1 kg or 1 kilocalorie is 1 kilowatt calories, right? Yo, this is 1 kilocalorie is equals to what? 1000 what? It's equals to what? 1000 calories, right? So we say 1 kilocalorie is equals to what? Sorry, 1 kilocalorie is equals to what? 1000 what calories. Please, it's very very important that you take note of all this. So one kilocalories equals to what? 1000 what calories. Now one calorie, take note, one calorie is equals to what? 4.2 joules. So it's equals to what? 4.2 what? Joules. So that is just how it is. 1 kilocalorie is equals to what? 1000 calories, and 1 calorie equals to what? 4.2 what? Joules. So that is just what how what it is. Now how can we effectively be able to measure this what heat of what reaction? To measure the amount of a heat of reaction, we use an instrument that is known as the what calorimeter, right? To measure the amount of what heat of what reaction. So we say our calorimeter, our calorimeter is used. This is an instrument used to measure. It's used to measure, or you can say it's used to determine. It's used to determine the heat, right? Is to determine the heat of what? A reaction. Is used to determine the heat of what? A reaction. Now please, in your own private studies, please try to understand the different types of what calorimeter. We also have what is known as the bomb calorimeter. Also gets to know where the bomb calorimeter is what being what applied, right? So we are also going to talk about what is known as what the heat of what solution, right? We all know that heat of what solution. Before we talk about the heat of what solution, you have to know what a solution is all what about, right? A solution is when what a solvent. A solution is when a solvent is dissolved in what a solute, right? So we say a solvent plus what a solute is going to give us what is known as what a solution. So let's say we assume our what sodium chloride, which is what a solute, our salt, which is what a solute, right? It's our salt, which is what a solute, being added in the what solvent, which is what a water. This is what is going to give us what a solution. So what is what a heat of what solution? What can be defined as what heat of what solution? The heat of a solution is the heat that is given out when a solvent is dissolved in water, right? So heat of solution is the amount of what heat 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 evolve, right? Is the amount of heat evolve. When you say evolve, is what the amount of what heat that is given out, right? Is the amount of heat that is evolved when what a substance, or when a solute is dissolved, not just dissolved in another substance, but is dissolved in what? A solvent, and that solvent is for water. So when it's dissolved in what? Water, right? So that is what is known as heat or what solution. Please, it's very very important that you take note of all these points that I'm listing out in this video, because the points are the necessary things as far as you are preparing for JAMB, which is what an objective exam. Even your WAEC, which also have the concept of what objective in it, right? So you have to understand all these points. And even in your theory, if you are preparing for any external exam like WAEC, NECO, where you can also be asked to define, these are the exact definition that is required, or that is required from what you, right? So that is just what it is. So let's talk about the Born energy, right? Let's talk about another important concept here, which is the Born energy, right? So the Born energy is the what average amount of what energy. Let's say, okay, this is what a Born. Let's assume this is what a Born, right? The Born energy is simply what the average amount of energy that is required for me to produce this thing, or that is required for me to break down this thing, right? So that is what is known as the Born energy. When we say energy, is the amount of what energy, right? The power, the abilities that is required for me to produce this, or the energy that is required for me to break down what this. So let's see how we can be able to get the definition of what Born energy from what the textbook what aspect. So in case you are asking your exam, you can be able to give them right, the way it was is supposed to what be. So we say the Born energy. We say the Born energy is the what is the average amount of energy. Say this is the average amount. Is the average. This is the average what amount of what energy, is the average amount of what energy associated, is the average amount of energy associated with the making, with the making or breaking, with the making or the breaking of 1 mole of a particular bond, or breaking of 1 mole, or breaking 1 mole of a particular bond, of a particular what bond, of a particular bond in its what gaseous what state, in its what gaseous what state. Just like I said, the amount of what energy, or the average amount of energy that is required to what produce or to make or break what one mole of a particular bond in its what gaseous what state. And when we talk about the concept of a bonding, we already know what a bonding is all about, because I've dropped a particular video where I'm talking about what chemical what combination, or what is known as chemical what bonding. Chemical bonding is when elements or when compounds what come together in order to attain what stability. Right. So this is the bond energy. So the amount of energy that is required to what produce or to make this bond, or the amount of energy that is required to what break down this bond, and not just to break it in a solid or a liquid state, but rather in its what gaseous what state. It is very important that you understand this what silent key point that I am talking about here. And also note that the bond energy is the same for all what homonuclear what molecules. So we say the bond energy is what is the same. The bond energy is the same for all what homonuclear what compounds. It's the same for all homonuclear what. This is homonuclear what molecules, or homonuclear what compounds, or let's say homonuclear molecules to be very accurate. So it says the bond energy is the same for all what homonuclear what molecules. Right. This is one. So example of a homonuclear molecule is about what hydrogen to what hydrogen, right? So this is the bond energy that is the same for all what homonuclear what molecules. We also have our what oxygen to what oxygen, right? So this is the what bond energy required for what all what homonuclear what molecules, and it is what the same, while it is different, right? It is different for what heteronuclear what molecules. So as the name is homonuclear molecules, when we say homo, that means they are what the same, and when we say hetero, that means they are what different. So when it comes to heteronuclear molecules, so this is an example of what heteronuclear what molecule. This is a different molecule, this is what a different what molecule. But when you change this our homonuclear molecules, so they are what the same, and the bond energy is the same for all what homonuclear molecules, and it's different for all what heteronuclear what molecules. And it's very important you take note of all these points that I am dropping in this what video. It is very important that you will take note. All right, we are also going to be talking about a very important what concept before we summarize by talking about the various laws of what thermodynamics, taking the first and the second law of what thermodynamics. Let's talk about what is known as what lattice what energy. Lattice what energy. When you hear the word lattice, that means what comes to your mind should be what crystals, right? So what comes to your mind should be what crystals. Please think me when you hear the word lattice. So we say lattice, right? The moment you hear word lattice, what should come to your mind should be what crystals. So what is lattice energy? The lattice energy of an ionic crystal, the lattice energy of an ionic crystal is the heat of formation. The lattice energy of an ionic crystal is the heat of what is the heat of formation, is the heat of what formation, is the heat of what formation of one molecule, of one mole of what ionic what compounds, or one mole of what ionic what compounds from widely separated gaseous ion, from widely what separated gaseous, from widely separated gaseous what ions, from widely separated what gaseous what ions under what standard conditions. Under what standard what conditions, right? So that is just what under standard what conditions, right? So that is just what it is, right? So the lattice energy of an ionic crystal is the amount of heat of what is the heat of formation of one mole of ionic compound from widely separated gaseous ion under what standard what conditions. It is very important that you get this what definitions, right? So from there we are going to be talking about a very important law, right, which is the law of what thermodynamics. When you hear the concept of what thermodynamics, so let's say thermodynamics, let's break down this thermodynamics. When you hear the word thermo, what we are talking about what is temperature, right? So thermo means what temperature, right? And dynamics means what movement. So what this one means what movement. So what we are talking about what is what temperature what transfer, right? Temperature what transfer, that means temperature or movement of temperature from one point to what another. That is what is known as the what thermodynamics. And now to make this class, let me know if you're actually following up. State the first law of thermodynamics for me. Drop it in the comment section. State the first law of thermodynamics, while I will state the second law of what thermodynamics. The second law of thermodynamics states that a spontaneous process occurs only if there's an increase in the entropy of the system, right? A spontaneous process will only occur. So the second law of thermodynamics states that a spontaneous process only occurs if there's an increase in the entropy of the system and it was surroundings. This particular law, which is the second law of thermodynamics, is focusing on what entropy. This law focuses on what entropy. This law focuses on what the entropy and what number two, which is what the free what energy. So it's focusing on what entropy and what free what energy. That is what the second law of thermodynamics is focusing on. Drop it in the comment section, the first law of thermodynamics. Let me know if you are actually following up this class. So this is basically everything you're supposed to know about what energy and chemical reaction. And like I said, for every class that we are done with, we are going to solve past questions based on that topic. And if you love this video, if you find it very educative and helpful in the course of your studies, please don't forget to hit on the red subscribe button and also share this video to your friends so that they can come here and get value. And in turn, I'll feel motivated to continue dropping videos like this, and so that we can grow together. Until I see you in my next video, always remember that you're wonderful, always remember that you're unique, and always remember that you're a pacemaker. And don't forget that through consistent practice, your dream of smashing JAMB UTME is very possible. I really love you. Thank you.